So 7.5 is all about analyzing graphs of quadratic functions. All right, so we're talking about analyzing graphs of quadratic functions. Right, so when we look at a quadratic function, right, let's just say this example of x squared, right? This is a quadratic function, right? One thing that you should understand is that you can always, and this is one thing that we really try pushing in this course, is to understand that you can always graph anything by a table, right? We can always graph anything by a table, right? So we can make ourselves a table, pick a couple of negative numbers, maybe 0, a couple of positive numbers. And get some ordered pairs and plot them. Plot this. Let me move this over to the side. Redo this again. That way I have room. Right, so we're just doing -2 squared, right? Gives us y. -1 squared gives us y. 0 squared, 1 squared, 2 squared. So what do we get? Looks like we get 4, 1, 0, 1, and 4, right? Mm-hmm. We should be able to graph this, right? So we have -1, -2, 1, 2, 3, 4, right? -1 and 1, 0 and 0. And we have 1 and 1, and we have 2 and 4, right? Looks like it's going to look something like this. Right. Some characteristics that we should understand. One of the characteristics, and let me go to a new page here. I'm going to definitely make this bigger here. Right. Right. So we should already understand that a quadratic function is always U-shaped. In other words, we call it a parabola. It has what's known as a vertex, which is the lowest or highest point. Right, lowest point would look like this. Highest point would be right here. So this right here, our 0, 0, is a vertex. It also has the axis of symmetry. Right, and this axis of symmetry is just is an equation which will always be x equals the x value of the vertex And it's just like this imaginary vertical line. And it's kind of like a mirror, where the left side equals the right side. Right, that's how I like to think about it. Right, so taking a look at this graph here, I state here that the axis of symmetry is an equation. And it's x equals the x value of our vertex. Here's our vertex. X value is 0. Therefore, x equals 0 is the axis of symmetry. And as I state, it's just an imaginary vertical line, kind of like a mirror, right? So if I were to put this vertical line right here on x equals 0, you should be able to fold this in half and see that this line and that line overlap. Obviously, if it was drawn to scale and perfect, right? Right, so that is the axis of symmetry, which is the equation of x equals 0. Any questions? Any questions so far?
No.
Okay. So what we're going to be doing here is we are going to be looking at some graphs and finding these vertex, axis of symmetry, maximum or min value, and graphing them. So before we talk about that, how do we find the vertex? Right? Well, if the function, if our function is set in this f of x equals a open parentheses x minus h close parentheses to the power of 2 plus k, the vertex can be found very easily. If it's set in this form, we have no issue. I mean, this is the easiest way of finding the vertex. The vertex is an ordered pair. And our vertex here will just be the opposite of h, that's your x value, and then whatever specifically the k is. So if your vertex is in this form, right, if your function is in this form, it's a piece of cake. Keeping in mind that this form has an open parentheses and a closed parentheses, and it has a power of 2. Which means there better be an open parentheses and a closed parentheses and a power of 2. If it has those things, we can find a vertex very easily. All right, so let's take a look at an example here. I say f of x equals 2, open parentheses, x plus 4, close parentheses, to the power of 2 plus 3. Here we can clearly see that it's in that form. All right, it has an open parentheses and it has a closed parentheses and it has a power of 2. So our vertex is the opposite of h. H is whatever's inside the parentheses. So what's my x value? Anyone know?
1.
So it's the opposite of h, and the h is whatever is inside the parentheses. So whatever number is inside the parentheses, it's the opposite of that.
-4.
There you go. Right? Here's our parentheses. The number inside is 4. What's the opposite of it? Negative.
Mm.
Make sense, y'all?
Okay.
Yeah.
Yes.
Right? So, -4. What about our y value?
3.
Yeah, the y value is k. And k is whatever is outside of that parentheses. Right? So here we see it to be 3. Nice and easy, isn't it?
Yes.
What about b? What would this vertex be?
+2,
Good, a +2 followed by a?
-4.
Very good, very good. Any questions so far? Moving on then. Example C. What would this vertex be?
-7, 0.
Very good, -7, 0. What we can always do is we can say, oh, it's in that form. It's missing something out here, so I just put a 0. That means the same thing, doesn't it?
Yes.
All right, so here we get -7 and 0. Very good, very good. Questions there? And how about one last one? This one's a little interesting, isn't it?
Mm-hmm.
Why is this one interesting? What is it missing?
Parentheses.
Parentheses. But can we write it like this? Well, let's think about it. Let's try to simplify this, okay? What's x plus 0? Before you
Zero.
answer that question, what's 1 plus 0?
0.
1 plus 0 is 1, right?
1. Yes.
What's 2 plus 0?
2.
3 plus 0?
3.
4 plus 0?
4.
X plus 0?
X.
Oh, so that's just X. And are we right back to the original problem? X plus 0 is X. We bring down that power of 2, don't we? We're right back to the original problem. Right? Which is just that. Which means we can, this is, and now from there, can't you find your vertex? What is our 0? What's our X value?
0.
0. And our Y value?
-3.
There you go. So very nice problems of finding the vertex. But now we get into something like this. Put a star here. And understand that D is a binomial. And E is a trinomial. Which means to find a vertex to a trinomial, we must do something different. To find a vertex to a trinomial, we have to do something different. We have to. All right? To find a vertex to this trinomial, we say that the X value equals -b over 2a, and their Y value equals f of -b over 2a. So that is what our vertex is. So it's not as easy. We have to do a little bit of work. All right, we have f of x equals x squared minus 8x plus 12. A is 1, B is -8, C is 12. Our x value equals -b over 2a. In other words, it equals what?
-8.
Negative, and then we have a -8
Mhm.
over 2 times 1, right?
Mhm.
And those two negatives turn into a
Positive.
positive. So now it's 8 over 2, or in other words, it's a 4.
4, yes.
So our x is 4. Questions?
No.
And now in order to find the y value, all we got to do is plug that. What do we get? 4?
Mm-hmm.
We plug that 4 into our original problem, replacing the x's with 4. So what do we get here? This is a 16 minus 32 plus a 12, right?
Yes.
-4.
There you go. So your vertex, our x was 4, our y was -4. A little bit more work when it's a trinomial, isn't it?
Mm-hmm.
Makes it wish that we wish every problem was like this, don't you think?
Yeah.
But that's not always going to be the case. Now there's a way to turn it into that. It's called completing the square, but that takes a little bit more work. It requires factoring. I think just using formulas make it a little easier. Any questions?
No.
So we just introduced 7.5. I really talked about, axis of symmetry, vertex. We're going to continue on because there's a little bit more that we can talk about here, like how to find exact graphs, incorporate the vertex a little bit more into some other questions. So tomorrow I'll continue with 7.5 and then see where we need to go from there.
Okay.
Okay, y'all. So any questions, comments, concerns?
No.
Well, y'all enjoy your Tuesday, and we'll see y'all tomorrow. Same
Okay.
time, same place.
Thank you.
You're welcome. Bye, everybody.
Bye.